All right, this is what we are doing in class on November 21st. Start with your warm-up, please. Your DLO is right here. November 20th is the date, and here is your warm-up problem. So please find this in your packet. Pause the video, take a second to answer yourself. You may consult your notes during the warm-up. You may always consult your notes during the warm-up. And the correct answer here, what terms describes this intersection? We've got plane T and plane P. They are intersecting right here, and the term that describes that intersection is a line. The intersection of two planes is a line. Okay. So that's our warm-up for today. So turn in your notes packet to 1.2, relationships between geometric figures, line segments, and distance. So our first question on that page is, what's the difference between a line and a line segment? And if you think back to our second warm-up, where we had all of those things and none of them were lines, the big difference here is going to be lines are infinite and do not end, whereas line segments have endpoints and a specific length. Lines are infinite and do not end. Line segments have endpoints and a length. That's what we should write down next to that question up at the top of our page. So, on this one, is this a line or a line segment? This is a line. This is a line. Remember, we use 2 points to name a line, so our possible names here are MP, MQ, or PQ, and the way that we would denote that they are lines is we would draw a tiny little line with the arrows above the name. Okay? The second one, is this a line or a line segment? Well, it has definite endpoints and definite lengths, so this is a line segment. And we could name it RS, ST, or RT. Well, the whole thing would be RT, but RS is a line segment, ST is a line segment, and RT refers to the whole thing. And the way that we would write each of those is with a single line, no arrows above the 2 points. Third, is this a line or a line segment? We could call this whole line ED, DF, or EF. It's a line. Or if we're talking specifically about the parts that have specific lengths, ED is a line segment on line EF. DF is a line segment on line EF, and EF is a specific segment on line EF. So if we're talking about these specific parts that have a specific length, that's a line segment that is part of a continuing line. Okay. So this is on your paper already. You don't have to write it down, but a line segment has endpoints that show where the segment begins and ends. That's how we know it has a specific length, because it has a beginning and an end. So now we're going to draw and label AB. Well, to draw AB, all we have to do is connect points A and B, and then label it. That's AB. That's line AB. Then they want us to draw and label BA. Again, all we have to do is connect those 2 dots. That's line BA. Pretty simple. So now we have a couple of questions. Are AB and BA names for the same line segment? Yes, they are. They are names for the same line segment because it doesn't matter whether we're talking about AB or BA, it's the same portion of the line. It doesn't matter where we start or end. It doesn't matter which one is the starting or ending point, because it's the same line. Next question is, what do you notice about the measurements of AB and BA? Well, let's see, there's BA, there's AB. One thing we might notice is that they're the same. They are the same measure. What math word describes that things are the same length? You may have heard this one before. Congruent. The word congruent means same length. The word congruent means that things are the same length or the same size. And the symbol that we would use for this, so this is the answer to question number 3. And then down in that blank, you need to write this symbol. You're going to be seeing this symbol a lot. This symbol, the equal sign with the little tilde over it, means that two things are the same size, same length, same measure. And that's going to finish our first page. Flip to the next page, and we see this. When looking at pictures in geometry, we have these little markers. These markers tell us that lines or line segments are congruent. So in this one, we see that all 4 are congruent. In this one, we can see that these opposite sides are congruent. So how might we use these? Well, when we see a diagram with these markings, we'll be able to say, well, if these 2 sides are congruent and this side is 10, then I know that this side is 10, so that I know that x is 10. If these 2 sides are congruent and this side is 23 and this one it just says y, I know that y is equal to 23. That is the majority of how we're going to use these. When we see 2 things are marked congruent, we can set up linear equations and solve for variables. It won't usually be this simple, but sometimes it will. Okay, so looking right below that, we're going to find the measure of each line segment. So right now they want us to find RT. RT is made up of smaller segments, RS and ST. So the way that we're going to find RT is we're going to add those lengths together. 2 plus 2.5 gives us 4.5 centimeters. Don't forget your units. 4.5 centimeters. In this one, we're being asked to find WX. We've been told that WY is 6 centimeters long. However, we're seeing these congruency markers, which means that WX and XY are the same length. And if they're the same length, then what we're actually seeing is that WX is going to be half the length of WY. So we divide 6 by 2 to find out that WX is 3 centimeters long. So now we're being given this, this problem. We have to draw a picture of line RS. We're finding RS. If S is a point between R and T, we can assume that these 3 points, S, R, and T, are all on the same line. And we're going to find the value of X and the length of RS in each of these. So if S is between R and T, our line is going to look like this. They're all collinear, R and T with S between. So in our first problem here, we see that RS is 5x, ST is 3x, and RT altogether is 48. So we sketch that out for this first problem. 5x, 3x, and the whole thing is 48. But using this, we can set up a linear equation. We can say that we know 5x plus 3x added together is going to give us 48 units. So we're going to combine our like terms. 5x plus 3x is going to give us 8x. And then to solve for x, all we have to do is divide both sides by 8, which gives us x equals 6. But remember, we're not quite done because we wanted to find x and RS. So all we have to do is look back up here, see that RS is 5x. We already know what x is, so we plug it in to find out that the length of RS is 30 units. RS is 30 units on its own. Okay, rest of the notes in the next video.